Okay, you should have this foldable in front of you. It's got a couple different formulas that we're going to be using. One to help us find arc length. So what we're trying to find when we're looking for arc length is what is the length of any segment of the circle, right? This arc right here. And the other one we're going to be using is going to help us find sector area, which is, okay, what is the area of a specific sector in this circle? And each of these sections show you the two different formulas we're going to use. So let's do a couple examples. Go ahead and open your foldable on the top half, and let's do a couple examples here. So here they want us to find the length of EF. So we're trying to find the length of this segment right here. So we're going to use the arc length formula. So the only value that we need to get from the picture is this one right here, right? The degree. And then this one here, we need the radius of the circle. So I'm going to use that formula. So the degree I'm using is 120 degrees. And you'll notice that in the formula, we're putting that over 360. So really, we're just looking at what fraction of the circle are we using. We're taking 1/3 of the circle. 120 degrees over 360 would simplify to 1/3. And we're going to multiply that by the circumference of the entire circle. Well, the circumference of the entire circle can be found by using the formula 2 times pi times r. So 2 times pi times 6 would give me the circumference of the entire circle. I'm going to multiply that by basically the fraction 1/3. If I simplify this, it's going to simplify to 1/3. And I'm going to multiply that by 12 times pi. 2 times 6 is 12. If I multiply 1/3 times 12, I'm going to get 4. So 4 times pi would give me my answer. So if they're asking for an answer in exact terms, in terms of pi, I would leave it like this. If they're asking me for an approximate answer, I can now grab my calculator, multiply 4 times 3.14 or 4 times pi, and round off to the appropriate number of decimal places. Now let's look at example 2. So again, I'm finding arc length, right? So I'm going to use this formula. And I see I'm dealing with a 60-degree angle. So I'm going to put 60 over 360, which is effectively the fraction 1/6 if I were to simplify that. Now they tell me here the diameter of the circle is 24. So be careful you read. Sometimes they're giving you diameter, sometimes radius. My formula is using radius, you'll notice. So the radius of that circle would actually be 12. So I'm going to multiply that by 2 times pi times 12. Or I could just keep it as 24 and know that that already accounts for the factor of 2, right? I could just multiply 24 by pi, but I'm going to simplify again. This is going to simplify to 1/6 times 24 pi. 1/6 of 24 is 4, so I would get an answer of 4 pi. If I want an exact answer, or I would use my calculator, and then I could approximate what the answer might be as a decimal. So that's how we're going to find sector area, right? Using this, or arc length, using this top formula. Let's look at the second formula, the one involving sector area. So notice again, the first part of this is the same. I'm really looking at what fraction of the circle am I dealing with, but this time instead of multiplying it by the formula for circumference, I'm multiplying it by the formula for area. So let's look at example 1 in the bottom half of your foldable. So again, they give me a sector that's 120 degrees. 120 degrees out of a 360-degree circle is really, again, 1/3 of the circle, right? So I'm going to really just find the area of the circle and then multiply it by 1/2. And how do I find area of a circle? Pi r squared. So I'm multiplying this by pi times radius squared, or pi times 16 squared. So I'd probably use my calculator to figure out what 16 squared is, which is 256. So I'm going to take 1/3 times 256 pi. Now again, depending on whether I'm looking for an exact answer or a fraction or a decimal, I'm going to simplify this depending on what my answer asks for, right? But I would now grab my calculator, multiply 1/3 times 256, that doesn't really come out to be a nice number. It's like 85 1/3. So if I wanted an exact answer, it might be something like 85 1/3 pi. If I want an approximate answer, a decimal answer, again, I'll use my calculator, multiply those together and get the decimal answer. So let's look at the example below it. So a circle has a radius of 12. Find the area of a sector whose central angle is 120 degrees. So again, another 120 degree angle. So again, it's 1/3 of a circle, right? So I would have 120 over 360 degrees. I'm going to multiply that by the formula for area of a circle, which in this case, again, is pi times radius squared. And they tell me the radius is 12. So pi times 12 squared, or 1/3 times 144 pi. And this time, if I take 144 and I want 1/3 of that, this does work out a little nicer. That's going to be 48. So again, an exact answer would be 48 pi. If I just want an approximate answer, grab my calculator, multiply 48 times 3.14 or 48 times pi, and again, round it off to the appropriate place.